Find the number of combinations and permutations that can be formed by taking 4 letters at a time out of the letters of the word. First bit mathematics, second ineffective, third is examination. Now, the meaning of combinations is you have to select how many ways 4 letters can be selected from the word mathematics, and permutation means how many words can be formed by taking 4 letters at a time. So the procedure to find the combinations and permutations is, first you identify how many times each letter is repeated in the word mathematics. So after listing how many times each letter is repeated, now you have to form the different cases. That is, in how many cases are there, so that you can select the 4 letters. It can be distinct or it can be combination of repetitions. And for each case, you calculate the combinations, that is how many ways you can select. And after the selection, you check how many ways you can arrange among themselves. So in the word mathematics, the letter M is repeated 2 times, A is repeated 2 times, T is repeated 2 times, whereas H, E, I, C, S is 1 time. So total number of letters are 11. In that, if I consider the distinct letters are 8. Now, the possible cases are, one case is 4 letters distinct we can select, or 2 distinct and 2 alike of one kind. That is, 2 alike means here 2 letters are same. Third case is 2 alike of one kind and 2 alike of another kind. Now, in the first case, 4 distinct letters. Because we are having 8 letters are distinct, the number of ways of selecting 4 letters from 8 is 8C4. Next, permutation means arrangement. So, permutation will come after the selection. That means 8C4 into 4 factorial. This 4 factorial corresponds to number of possibilities of arranging 4 letters among themselves. That is what 4 factorial, because they all are distinct. The second case, 2 distinct and 2 alike. Now, 2 alike means 2 are same letters. That means those letters can be either M, R, A, or T. That means it can be one of them among the 3. That is what 3C1. Now, after the selection of 2 same letters, now you are having 2 more distinct letters we have to choose. Now, there will be 7 distinct letters will be available for 2. That means it will be 7C2. Now the combinations will be 3C1 into 7C2. Now the arrangement among themselves will come under permutation. So 3C1 into 7C2 into 4 letters we have selected. So 4 factorial. Among them 2 are same. So that's why in the denominator 2 factorial. Third possibility, 2 alike of one kind and 2 alike of another kind. Means 2 letters are same. Again another 2 letters are also same. Now, so those 4 letters has to come from either M, A, T. That means you have to choose the 2 among the 3. That is what 3C2. Now after this selection, now the arrangement will be 3C2 into 4 factorial upon 2 factorial, 2 factorial. Because 2 letters are same, again 2 more letters are same. Now when you calculate the sum, so number of combinations are 136 and number of permutations are 2484. So in case of the word ineffective, like in mathematics, here also you list the letters, how many times each letter is repeated. So I is repeated 2 times, N is 1 time, E is 3 times, and F is 2 times, C is 1 time, T is 1 time, V is 1 time. So total number of letters are 11. Out of them 7 are distinct letters. Now let us list the cases first. So one case can be 4 are distinct, and second case is 2 alike and 2 distinct. Third case is 2 alike and 2 alike, and one more case is 3 alike and 1 different. Why 3 alike, 1 more different is there is a 1 letter which is repeated 3 times. Now, so the number of combinations in each case, when 4 are distinct, 7 distinct letters are there. So 7C4, and the arrangement will be what 7C4 into 4 factorial. When 2 are alike and 2 are distinct, 2 are alike. So it can be from I, or it can be from E, or it can be from F. That means 3C1. Now after the selection of 2 alike, now 2 distinct. That means 2 distinct has to come from 6 distinct letters, that is 6C2. Now the arrangement will be 3C1 into 6C2 into 4 factorial upon 2 factorial. Third case, 2 alike and 2 alike. So this 2 alike and 2 alike has to come from either I, R, E, or F. That is 3C2. And the arrangement will be 3C2 into 4 factorial upon 2 factorial into 2 factorial. Now, fourth case, 3 alike of one kind and one is different. So 3 alike is the only one letter which is repeated 3 times. That's why it is 1C1 into 6C1 because 6 distinct letters are available. Now the arrangement will be 1C1 into 6C1 into 4 factorial upon 3 factorial. Now the number of combinations are 89 and the number of permutations are 1, 4, 2, 2.
Sir.
So for the word examination, there are total number of letters are 11. In that, A is repeated 2 times, I is repeated 2 times, N is repeated 2 times. The remaining letters are repeated only 1 time. And total number of distinct letters are 8. So here also, only 3 cases are possible, 4 distinct, 2 alike and 2 distinct, and 2 alike and 2 alike. So the number of combinations and the number of permutations. Now, how to calculate 100 C100 plus 101 C100 plus 102 C100 and so on 2019 C100. Third, if n equal to mc2, then what the value of nc2 upon n plus 1 C4? Fourth one, find the number of ways in which 3 numbers in arithmetic progression can be selected from 1, 2, 3 and so on n. Fifth one, find the number of ways of selecting 2 numbers from the set 1, 2, 3, 4 and so on 3n so that their sum is divisible by 3. Yeah. So in the second problem, 101 C100, 101 C100 and so on 2019 C100, we have to use the formula NCR minus 1 plus NCR equal to n plus 1 CR. Now, to use this formula, 100 C100 value is 1. Again, that 1 I can rewrite as 101 C101. That value is also 1. Now I can apply the formula of NCR minus 1 plus NCR for the first 2 terms. That is 101 C101 plus 101 C100. Now sum of these two will become 102 C101. Now again apply the same formula for this 102 C101 plus 102 C100, which becomes 103 C101. So if you go on proceed like this, the finally you will get 2020 C101. So in the third problem, n equal to mc2 and mc2 means m into m minus 1 by 2. Now nc2 in terms of m will be m into m minus 1 by 2 into m into m minus 1 by 2 minus 1 upon 2. Now this inside can be factorizable, which is m into m minus 1, m minus m plus 1 upon 8 and m plus 1 C4. So starting with m plus 1, 4 factors in the numerator by reducing 1 in the denominator, 4 factor, and go for the ratio and simplify. The value will be 3. So for the fourth problem, find the number of ways in which 3 numbers in arithmetic progression can be selected from 1 to n is. You have to consider 2 cases. N can be even or n can be odd. Now let us consider the first case. When n is even, then I can take as n equal to 2m. Now out of 2m numbers, there will be m odd numbers will be there and m even numbers will be there. And we need to choose 3 numbers. If I consider a, b, c, now once they are in AP means I can write 2b equal to a plus c. I mean left side is even. Then right side also should be even. That means again 2 further cases will be there. So both can be even, that is a and c, or both can be odd. Now selection of 2 when both are even. Now there are m even numbers are there and 2 we need to select, so mc2. And both can be odd. There are m odd numbers are there, selection will be mc2. Now these are the different cases, so you have to add. So 2 into mc2, which is if you simplify in terms of n into n minus 2 by 4. Now for the second case, when n is odd, I can choose n equal to 2m plus 1. So when n is 2m plus 1, there will be m plus 1 odd numbers and m even numbers will be there. Now again first case, both are even, both are odd. When both are even, Now m even numbers are there, so number of ways of selection is MC2, and both are odd. M plus 1 odd numbers are there. Number of ways of selecting 2 is m plus 1 C2. Here also these are the two cases you have to add MC2 plus m plus 1 C2 and simplify and replace m in terms of n. Then you will get as n minus 1 whole square by 4 when n is odd, and n into n minus 2 by 4 when n is even. So to find the number of ways of selecting two numbers from the set 1 to 3n so that their sum is divisible by 3. So we can group these numbers as numbers which leave the remainder 1 when divided by 3, numbers which leave the remainder 2 when divided by 3, and numbers which leave the remainder 0. That means multiples of 3. That means I can list these numbers as a group 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. That means in each group there will be n numbers. Now, in the first group, there are n numbers, second group n numbers, third group is n numbers. Now, we need to select two numbers such that sum is divisible by 3. That means from individual group, let us identify whether can we select any two numbers or not. Now, if I select any two numbers from the first group and if I add, it is not divisible by 3. Whereas, if I take second group also and select any two numbers and add, it is not divisible by 3. Now, if I choose a third group, in that if I select any two numbers and add, it is divisible by 3 because the sum is always there multiple of 3. That means the number of ways of selecting two numbers from the third group is NC2. Now the another case will be one number from one group and one number from the another group. So if I choose one number from the first group and one number from the second group, the sum is always divisible by 3 because if I choose 1, 5, 1 plus 5 or 2 plus 4 or 1 plus 11, whichever numbers if I add, one from the first group, one from the second group, the sum is divisible by 3. That means I can select one from the first group means NC1, one number from the second group is again NC1. So NC1 into NC1. Now let us consider first group and third group. So when I select one number from the first group and one number from the third group, the sum is not divisible by 3. In the same manner, one number from the second group and one number from the third group, also it is not divisible by 3. That means there will be only two cases. So NC2 plus NC1 into NC1. So if you simplify, you'll get 3n square minus n upon 2. So the next one is in how many ways can the letters of the word permutations be arranged if there are always 4 letters between P and S? So in this problem, in how many ways can the letters of the word permutation be arranged if there are always 4 letters between P and S? Now the total number of letters are 12, out of which only one letter is repeated, T. Remaining all are distinct. Now we have to identify first how many cases will be there for the positions of P and S. So one possible case is P can be in the first position and S can be in the second position. Or another case is P can be in the second position or S can be in the 7th position. So like that you will be having 7 cases. Now if I consider the first case, P and S. Now P and S are fixed. Now the remaining letters are 10 and 10 blanks are there. So that can be arranged in 10 factorial ways. And among them, 2 letters are same. So the number of arrangements will be 10 factorial upon 2 factorial. Now there will be 7 cases. That's why it will be 10 factorial upon 2 factorial into 7. Now P and S also can be interchanged because it is mentioned as what between P and S. So P and S arrangement will be 2 factorial. So this 2 factorial gets cancelled. The value will be what 7 into 10 factorial.